Moving on. All right, let's go back to another story that we've talked about in the past. Bennu and Osiris Rex. Really interesting mission. I've been following this one for a while just because I think it's important and cool. So this was yesterday. Head scratcher. First look at asteroid dust brought to Earth offers surprises. This is nature.com. 2.5 months since NASA's first asteroid sample mission landed safely on Earth. Technicians have carefully plucked more than 70 grams of asteroid dust and pebbles from the outside of the spacecraft's canister. It's more than 10 times the amount ever brought back from an asteroid. But these early discoveries are still a long way from where planetary scientists had hoped to be after the September 24th touchdown. Last month, researchers at the Johnson Space Center in Houston, Texas, discovered that 2 of the 35 screws that fasten the lid of the sample return canister couldn't be opened, blocking access to the remainder of the space rock. Curators used tweezers to pull out what they could, but NASA is not making new screwdrivers so it can get into the equipment. It flew billions of kilometers across the solar system to the asteroid Bennu and back. Oh, but NASA is now making new screwdrivers. Sorry, they are making screwdrivers. I was going to criticize them, be like, why are you not? Until then, it's kind of like Schrodinger's sample. A planetary scientist said, we don't know what's in there. Okay. All right. When pieces of asteroid fall to Earth as meteorites, they pass through the planet's atmosphere. All right. Among the hull is a 3.5 centimeter long rock, the biggest collected at Bennu. It is so big that it jammed the spacecraft collecting mechanism open when Osiris Rex briefly touched the asteroid surface in 2020. Like nearly all of Bennu material, the rock is dark colored almost to the point of being black, but it also has a bluish sheen to it. That's similar to highly reflective boulders that Osiris Rex photographed on the surface of Bennu as it was orbiting. Other smaller chunks within the Bennu sample have light-colored reflective coatings, making them appear bright against the other dark pebbles. But under a scanning electron microscope, they showed themselves to be colored in a highly brittle layer that breaks easily to reveal a darker interior. Chemical analysis show that this light-colored surface skin contains magnesium, sodium, and phosphate, a combination rarely, if ever, seen in meteorites. Uh-oh. Other bits of Bennu contain hydrated clay minerals known as phyllosilicates, as well as carbonates, magnetite, and sulfide minerals. All of these were anticipated but are good to see. Also, it contained organic compounds, carbon-carbon or carbon-hydrogen bonds, including a large amount of the ringed molecules known as polycyclic aromatic hydrocarbons. All right. Very cool. So they have been making some progress with this, but this mission has been taking such a long time to just get into the data, to get into what exactly is going on with this mission, and unfortunately, for now, we just gotta wait, which is not a lot of fun. And frankly, it stinks because you really want to see them live up to the expectations, and I assume they will. But the expectations that they set out to basically say this is going to be the next big thing. This is going to basically tell us whether or not, or greatly help us in the study of seeing whether life here on Earth was a result of meteorites or asteroids containing organic chemicals and organic compounds to seed the Earth and ultimately bring life here. Because there is an idea that life here on Earth was seeded by these outside sources that had H2O, they had hydrogen, they had carbon on them, they had all these different molecules and compounds that helped to create life billions and billions of years ago. So they were hoping that this is going to be something that really gives us a lot of evidence to whether or not that is true. And so far, it's just been really slow, which kind of stinks. But that is not the worst thing.